Hello everyone, this is Pushpendra Kumar. I welcome you all to this lecture. In this lecture, I am going to discuss combinational circuits and sequential circuits. So let's start the discussion. What is combinational circuits? I'll talk first about the combinational circuit. In any kind of electronic circuit, we pass certain number of inputs and that circuit will give us output. So let's say I'm assuming this is a circuit and here we are passing certain number of inputs. Let's say input 1, 2 and so on, and let's say we are passing some n number of inputs like this. So there are certain other inputs also. So I'm saying let's say this is input 1, input 2, so I'm taking like a1 a2 till an, and I'm also assuming that this circuit is generating certain outputs. Outputs may be any number like m, so I'm assuming here m number of outputs are being generated. So this is, let's say, b1, b2 and let's say bn. So we are passing n number of inputs. Here I am writing inputs and here I am writing outputs. If the circuit is combinational circuit, the present output, so I'm saying present output or current output, present output will be dependent on the present input only. So whatever was the previous output, it doesn't affect the present output or current output, right? So that is the basic property of combinational circuit. So I'm writing here this is a combinational circuit. Okay, the present output is directly dependent on the present input. There are multiple examples we can take. So let's say we can take the example half adder, full adder, multiplexer, demultiplexer or in short demux, encoder, and decoder. So all these are the combinational circuits. Now let's talk about the sequential circuit. So in combinational circuit, if we add a memory element, then this combinational circuit start behaving like sequential circuit. So let's see it. Let's say we are having a circuit, a similar circuit, where we are passing certain number of inputs and we are getting some outputs. So at least one output we will get. The output may be more than one as well. So let's say few inputs we are passing like this. So certain number of inputs and outputs we are getting here. So certain number of outputs we are getting. Okay. Sorry. So let me complete it now like this. Okay. So I'm assuming that there are n number of inputs are coming So you can take any name like A1, A2 or I1, I2. If you feel like, you can take I1, I2, IN. And output you can take O1, O2, ON. I'm taking here like B1, B2, dot, 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 BN. So M number of outputs we are getting. Now, because this is I'm going to draw as sequential circuit, there'll be a memory element. So let's say I'm assuming this is a memory element. And what is the important thing about memory element? It is capable to store the data. Okay, so let's say whatever the output we are getting here, these outputs are getting passed to a memory element. That means the output is being stored. So let me write it. This is memory element. Okay, sorry. So the output is coming like this and getting stored like this, and so on till M. All are being stored in that manner. Right. Now these outputs will be passed as input also. So let me connect all this. So let's say I'm drawing here like this, like this. All these are being passed as input so like this it is being connected, right? So whatever is getting stored in the memory element, that is being passed as input. And I'm writing here, this is actually the combinational circuit. So I'm writing here combinational circuit. This is a combinational circuit only. Okay, so it behaves like you pass some input, it will generate output. Only this memory element is making the whole circuit as sequential circuit. So it is utilizing the previous output as the input. So here I am writing previous output. So let's write it like previous output and here I am writing present output or current output. Okay, and these are the inputs. I'm writing inputs and these are the current output, right? So this is the representation of sequential circuits. There are many sequential circuits like flip-flops. We are having counters. There are asynchronous and synchronous counters. So few examples you can take: flip-flops, counters, right, etc. So with this, I am ending this lecture. In next lecture, we will be talking about half header and full header. Thank you.